So now let's integrate the product of e raised to 2x sine x dx. So again, let us make 3 columns, one with the sine and the other two with the derivative and integral column. So now we will choose the e raised to 2x to be in derivative column and sine x to be in the integral column. So the derivative of sine x, or e raised to 2x rather, is 2e raised to 2x, and if we derive it again, it will become 4e 2x. Since this is going nowhere to 0, it's just getting up and up, or bigger and bigger. Let us move on to the integration. To integrate sine x, the answer would be negative cosine x, and if we integrate it one more time, the answer would be negative sine x. So since this is going nowhere either, and as you can see, this e raised to 2x sine x is equivalent to 4e2x minus sine x if we move the constant out. So let this be derived to the left. So the answer would be, if we multiply this diagonally, the answer would be e 2x negative cosine x, negative times negative, positive 2e 2x sine x, and integrate the 4e 2x sine x dx. So it will become, we will move the constant out. So this will become 4e, integrate 2x, the product of 2e raised to 2x sine x dx. So this and this will be now the same. So let's add both sides for integration of the product e 2 raised to 2x sine x dx, and on the other side we add again. So this will become e 2x sine x dx plus 4 e 2x sine x dx is equals to, this one will be cancelled, e 2x cosine x plus 2e 2x sine x. Combine, because this is addition and addition, so let us combine. It will become 5, and the integration of the product e raised to 2x sine x dx times e 2x cosine x plus 2e 2x sine x, and divide both sides by 5. The answer would be e 2x cosine x all over by 5 plus 2e 2x raised to 2x rather sine x all over by 5 plus c, because we are integrating. So this is the final answer. Now let's move on to our last equation, which is the integration of the product x to the fourth ln x dx. So let's now again make a column of d and I and design positive, negative, positive, negative. Again, let us choose whether these two terms or two functions will be in the derivative column or the integral column. If the x to the fourth is in the derivative column, it can reduce to 0 when it comes. While the ln of x, if we integrate the ln of x, it will be complicated. So let us put the ln of x be our derivative, be in our derivative column. So ln of x in our derivative column, and the integral column will be the x to the fourth to be integrated. So the derivative of ln of x is 1 over x. If we derive it again, it will be negative 1 all over by x squared. So now we have come to realize that this will not nowhere going to 0, but gonna be smaller and smaller. So let's move on to integration. If we integrate x to the fourth, the answer would be x to the fifth all over by 5. So since this is going nowhere again, let us integrate it to the left side. So the answer would be ln of x times the x to the fifth all over by 5. Since this is negative, the integration of the x to the fifth times 1 all over by x dx. Since we are integrating or we can integrate this x to the fifth over 5 times 1 all over by x dx. The answer would be x to the fifth ln of x all over by 5 minus, let us put the constant outside, minus 1/5 times the integral of, since this is in the denominator, let us cancel out, and this will be 4 to the x fourth dx. The answer would be x to the fifth ln of x all over by 5 minus 1/5 the integral of x to the fourth is the x to the fifth all over by 5. The final answer would be x to the fifth ln of x all over by 5 minus x to the fifth all over by 25 plus c. That is the final answer. So that is the 3 scenarios in using tabular method or the DI method. Thank you.